In this lesson, we're going to be talking about man-in-the-middle attacks. So what's a man-in-the-middle attack? Well, a man-in-the-middle attack is pretty much what it sounds like. And you can think about the game that maybe you played as a child where you're called Monkey in the Middle. And the idea was it was sort of a keep-away game where two people on the outside were throwing maybe a ball back and forth, and the monkey in the middle, the goal was to capture the ball. So the idea behind a man-in-the-middle attack, I guess, is a little bit similar to that, where there's this traffic that's going back and forth between these two endpoints, and the idea of a man-in-the-middle attack is to capture that traffic. And ideally, you want to capture the traffic in such a way that the two men on the outsides or the two systems on the outside aren't aware of what's going on. And there's a lot of different ways of doing man-in-the-middle attacks. A long time ago, when we weren't quite as careful about the way that we were transmitting information, you could do things like maybe a TCP sequence number attack where you could actually grab the traffic and not only intercept it, but communicate with the other end by doing sequence number prediction. Our sequence numbers have gotten a lot better over time, and so that's a lot harder. There are, though, other attacks that still work, and there are a lot of them. I'm going to talk about a couple here. Right here, I've got a program called Ettercap up, and Ettercap makes the process of man-in-the-middle attacks much easier. So there's a few things that I can do, or a couple of things anyway, I can do with Ettercap, and I'm going to turn on the unified sniffing, and now I can do man-in-the-middle. So I can do ARP poisoning, I can do an ICMP redirect, I can do port stealing, or DHCP spoofing. And right now I'm actually going to do ARP poisoning because it's one of the easiest things to do. So what ARP poisoning does is it makes use of the layer 2 protocol ARP, which is the address resolution protocol. What it actually does is it sends out these ARP messages indicating that IP addresses belong at the layer 2 address of this particular system. So the first thing I need to do is bring open the host list, and I've got a host list here, and I'm going to add a bunch of these to target 1, and I'm going to add a bunch more to target 2. And you can see the status down at the bottom. It added a bunch of the hosts to target 1 and a bunch more to target 2. Now, what I can do now is turn on the ARP poisoning. So I'm going to turn on the ARP poisoning, and I've actually got Wireshark open here. I can go capture traffic and see what's going on and actually show you what's happening. Now, let me take a look here. So my address is 192.168.1.20. So let's go back over to Wireshark and see if we can find some traffic that doesn't actually belong to us. Now, before I do that, because I'm seeing it go by, let me show you the ARP messages. So you can see there are a whole lot of ARP messages, and a lot of these say this IP address is at, and the MAC address that's associated with that would be my MAC address. So let me stop up here. So you can see here the is at messages, and here's all of the different IP addresses, and they all point at the MAC address, and that MAC address happens to be mine. So what that's doing is that's forcing all of the traffic on the network over to my system. And so we should be able to see everything going on this particular network and see it all showing up here. So, for example, here's one. So remember, my address is 192.168.1.20, and under normal networking rules, since I am on a switched network, only traffic coming to me should be showing up at my system. But what I've got here is traffic going from 192.168.1.16, and it's going to 192.168.1.43. Neither of those are me, and yet that traffic has shown up at my system. So this is because of this ARP poisoning attack that I have been doing. And you can see a lot of other messages here. So we've got 192.168.1.35 to 192.168.1.23. So there's a whole conversation that's going on there, and it's showing up at my system because I'm doing this ARP poisoning. So this again is just one example of doing a man-in-the-middle attack, and it's a pretty good one unless you're working in an enterprise environment where there may be something set up that would prevent these ARP messages, and they're called gratuitous ARPs, and of course they're called gratuitous ARPs because we're sending out messages that haven't been asked for. So if you're running in a network that is looking for these gratuitous ARPs and either shutting them down or alerting on them, then you may have problems doing this type of attack. But as I said, there's other attacks that you can do, and Ettercap, just as an example, Ettercap has these 4 different man-in-the-middle attacks it can do. The ARP poisoning that we've been talking about, it will do an ICMP redirect, it will do port stealing, and it can also do DHCP spoofing. So there are a lot of different ways of doing man-in-the-middle attacks. It's a way of getting data to a system that shouldn't otherwise see it. And this may be something that you run into from time to time where there's some data that's gotten out and you may need to be looking for these gratuitous ARP messages, or maybe you're looking for DHCP messages that look a little bit weird or unnecessary or unexpected in this particular network environment. And again, this is one of those cases where, as we'll talk about in another lesson, where you may want to be using some sort of intrusion detection system that would notice this type of attack and alert you to it, so that if you are investigating something that has to do with something like this, you will have a starting point, or at least a way of knowing what's going on.